Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Aizat Abadi bin Abdul Hadi. I am from BEEI 2/1, fourth year student in University Technical Malaysia Melaka. So today I will introduce to you about my project entitled Rainwater Energy Harvesting System via Gutter Application. As Malaysia is known for its constant rainfall and heat due to its position at the equator, there are two types of monsoon in Malaysia, which is northeast and southeast monsoon. Due to the monsoon, the rainfall is abundant and consistent throughout the year. Hence, Malaysia is the perfect country to benefit the rain gutter system. So, let's move to the project poster. So, the project poster consists of project description, introduction, objectives, problem statement, creativity and inventiveness, potential of commercialization, project features, methodology, result and analysis, and last but not least, which is conclusion. First of all, we start on the project description. The Rainwater Energy Harvesting System, which is RHS, will use 3D printed turbine model as one of the main components. The RHS main target is to put a mini turbine at the downspout of the gutter where the highest potential energy generated. Next, the turbine is connected to the generator, and as the turbine spins, there will be an exchange of energy which is mechanical to electrical energy. Last but not least, the output is mainly used for small-scale application as the load, such as to charge a smartphone and lights LED lights. Next, we will move on to the introduction. The RHS tested by two different sizes of 3D printed Pelton turbine to analyze the performance in order to achieve the highest efficiency. The 3D printed turbines are chosen from the best analysis result of testing on SolidWorks static simulation using stress and strain function. Using a DC motor as a generator connected to the iron shaft by using gear belt alongside the 3D printed Pelton turbine. The generator will connect it to the charging circuit that's stored inside a black box. Next, we move to the objectives of the project. The objective is to develop a rainwater harvesting system via gutter application. Next is to identify the suitable types of turbine used without deformation. So we already simulate on SolidWorks simulation before that in order to identify the suitable types of turbine. Last, to analyze the performance of rainwater harvesting system via gutter application. After that, I will continue to the problem statement. Rainwater harvesting has been practiced for many years. In fact, a lot of energy has been wasted from the rainwater. It will be a huge loss to not fully utilize rainwater potential to the max. Even now, people are using rainwater harvesting for toilet water, car wash, and more. Actually, the renewable energy can be produced before the rainwater use for that purposes. It is like kill two birds with one stone. After that, we will continue to the methodology. As you can see here, the methodology consists of the flowchart of the project, which start here, then problem identification, which is we need to perform study of hydropower generation, perform research and literature review, and last but not least is collecting data of flow rate of rainwater, area of the rooftop, the length of downspout, and the type of the generator. Then we calculate the expected power. The expected power calculation includes the flow of water, the height, the density, and the gravity. Next, move on to the software parts, which is familiarization of the SolidWorks software. The selected turbine undergoes SolidWorks simulation testing resulted static displacement, stress, and strain, which is as you can see here. There are two types of turbine tested, which is Pelton turbine and overshot water wheel. Then the lowest value of tested result will be used in the full system testing, which is here, to determine the type of turbine used. Last but not least, to assemble the prototype. Then testing, if successful, that is the end of the flowchart. If not, we need to find the error and assemble prototype again. So this is the prototype and the full design of RHS system. Next, we will move on to the result and analysis. As you can see here, there is the histogram of 10 cm versus 15 cm of 3D printed Pelton turbine performance. This histogram consists of average voltage, average current, and average power by the two different size of turbine, which is 10 cm and 15 cm. The data shows that 15 cm 3D printed Pelton turbine generated more power than the 10 cm. Almost 50% difference on average voltage and current data collected by the 15 cm 3D printed turbine. 5 cm difference gave gigantic changes on the performance produced. Almost 80% differences regarding the average power produced between the two turbines. So we can conclude that the 15 cm produce or better than the 10 cm. The bigger the size of the 3D printed Pelton turbine, the higher the performance and the higher the average power produced. After that, we will continue to the conclusion of the project. The purpose of this project was to provide energy to charge mobile phones or LED lights in area with a lot of rainfall. If the system used in June and July of the month, in leisure the system will not even be able to start because it is a dry month. It means the rainfall rate is lower on that month. Therefore, the smartphone may not be charged due to low input, which is rainwater. The RHS would be more cost effective if the energy produced was able to fast charging the smartphones. Last but not least, more energy could be generated if a higher efficiency and the modification of the circuit was achieved. After that, we will continue to the last three, which is creativity and inventiveness, potential of commercialization, and project features. The first one is creativity and inventiveness. The shaft collars. There is two shaft collars at the end of the iron shaft is to keep the turbine from slipping down the shaft as soon as water begins touching it. After that, the shaft material. The material that we use is stainless steel in order to prevent it from corrosion from forming. 10. 3D printed material. A cheaper material can be considered in order to make the RHS be more cost effective. The one that we use is PP copolymer materials, which is waterproof, and it is a good 3D printed, but it is a bit expensive. The last but not least is the charging circuit. It will be good if we can make a fast charging circuit according to the variants such as 18 watt and 30 watt. The next one is the potential of commercialization. The system can be marketed but low in customer requirement and can be marketed if it is done on a larger scale, which means higher power produced, and it can be marketed in rural places. Finally, the last one, project features. The charging circuit produces stable output power, lightweight hardware, cost effective, and last but not least, small and high mobility. Now, let's move to the demonstration of the project. So, this is the full system design of rainwater energy harvesting system, which is RHS. This is the DC motor that acts as a generator. Then it is connected to acting gear that attach to 2mm iron shaft via plastic gear belt. Next, the 15cm diameter 3D printed Pelton turbine is attached on the iron shaft beside the acting gear. As the turbine spins, there will be an exchange of energy, which is from mechanical to electrical energy. From the input, which is the generator, is connected to the charging circuit. The red LED will turn on if there is current flow through the circuit. The output is USB port Type A that needed to charge a smartphone. So the first testing is to detect if there is any power produced from the RHS. As I said earlier, the water that strike the turbines will convert mechanical to electrical energy. Then the iron shaft will spinning alongside with the turbine, and it will move the gear set and gear belt from the generator. As you can see here, the red LED lights up because there is power produced on the system. So now we are ready to test our RHS system. Oh yeah, before I forget, the potentiometer acts as a voltage control. So let's continue. There are many things to consider when we are talking about charging a smartphone, such as the voltage needed to charge a smartphone. A certain value of voltage is needed to charge a smartphone, or it will never be charged if the voltage was not on par. The voltage measured is 1.99 plus minus 1. Finally, the RHS is ready to be tested. After measure the voltage and current produced by the system, we are moving to the final objectives, which is to charge a smartphone. As you can see here, there is a transparent barrier in order to avoid the water to reach the black box containing the charging circuit that can may damaging the charging circuit. Yes, the smartphone is being charged by the rainwater energy harvesting system.